This lecture is a little different than the other lectures, okay? How do you watch this lecture? This lecture is going to be good both for the textbook homework due on October 1st and the textbook homework due on October 6th. You're going to watch the first part of this lecture before 10:01 and the second part of this lecture before 10:06. So first you want to attempt the assigned textbook homework completely on your own. Then you're going to want to go to Blackboard. And for 5.2 number 21, this is for the homework due on 10:01. And then also for 5.2 number 69, this is for the homework due October 6th. Compare your proofs to those available and the solutions to select textbook problems. Third, you're going to watch this video with your completed proofs in front of you, and you'll make improvements to those proofs as needed. So you'll watch the first part of this video for the homework due 10:01, and then the second part of this video for the homework due 10:06. Okay, so first of all, we're going to do number 53 from the homework due on October 1st. On the left-hand side, what we want to do is change both of these fractions into complex fractions. So what I want to do is replace secant with 1 over cosine and replace cosecant with 1 over sine. And then I can simplify these complex fractions. Remember that dividing by a fraction is the same as multiplying by the reciprocal. So this first term becomes cosine squared alpha, and this second term becomes sine squared alpha. And that's convenient because cosine squared plus sine squared is equal to 1. So then my next objective is to try to make what's on the right-hand side equal to 1. And if you flip to the back of the book where you have your Pythagorean identities, you'll notice that the one with secant squared is tangent squared plus 1. So because tangent squared plus 1 is equal to secant squared, that means that secant squared minus tangent squared is equal to 1. So now we have the left-hand side equal to the right-hand side. For number 55, we want to start by observing that on the left-hand side we have the difference of squares. So we'll go ahead and factor that. To move my line over. Okay, so now let's look at our difference of squares. We have sine squared plus cosine squared. That's equal to 1. It's important for your proof that you actually write this 1 because this 1 is a substitution. You are replacing sine squared plus cosine squared with 1. So at least in this line you need to include the 1, and then in subsequent lines you can drop the 1, but make sure you include it when you do your substitution. Now in my next line I don't need the 1 anymore, but sine squared minus cosine squared, how are we going to make that equal to 2 sine squared theta minus 1? You have a variety of options. So one thing you could do is you could, on the right-hand side, remember that 1 is equal to sine squared plus cosine squared. So you could replace your 1 with sine squared plus cosine squared, and that would end up simplifying to this. Alternatively, you could just continue to work on the left-hand side. Ultimately, you just need to replace one of these two. You would want to replace the cosine squared. And the cosine squared is equal to 1 minus sine squared. So you could do that. Okay, so I have just completed this already. because I thought I was recording earlier and I wasn't. So let me walk you through what I did here. I'm going to erase over here actually. What I have right here is first I made the observation that the difference of squares, sine to the fourth minus cosine to the fourth, can be split into sine squared plus cosine squared times sine squared minus cosine squared. So that's your difference of squares. And then you can replace sine squared plus cosine squared with 1. Make sure you include the 1 in this step because you are using a Pythagorean identity and you need to show the use of that Pythagorean identity. Once you have done it in the first line here, for subsequent lines, you can drop the 1. But it is important that you include the 1 when you do the substitution. Okay, so now I'm left with just sine squared theta minus cosine squared theta. So then what I could do, and there's multiple options. You can continue to work on the left-hand side until you make it look like the right-hand side, or you could work on the right-hand side for a little bit, and I'm going to show you that. If I replace 1 with cosine squared plus sine squared, then after using the distributive property and rearranging the terms, I end up with 2 sine squared theta minus sine squared theta minus cosine squared theta. And then that can be simplified further. 2 sine squared theta minus cosine squared theta, and then you're done. For number 57, a very common trick is that when you see conjugates together, it's good to go ahead and just multiply this fraction by the conjugate of the denominator. Okay, it's just a trick that you will acquire through frequent use. So what I would want to do, let me move the 57. In general, it's good not to write the number right next to the fraction in case you might need to multiply the fraction by something. But I'm going to multiply this by 1 minus cosine x over 1 minus cosine x. Okay, this may or may not help. It may or may not work, but it's a common trick. Okay, so I'm going to try it. Now for my numerator, I have 1 minus cosine x quantity squared. I may or may not want to expand that, so I'm going to leave it like that for now. And for the denominator, I now have 1 minus cosine squared x, which I was motivated to combine because I can see that this is going to turn into sine squared x using the Pythagorean identity. So now I have 1 minus cosine x quantity squared over sine squared x. And I don't know what else to do at this point with that, so I'm going to pause here and now work on the right-hand side, and hopefully I'll find something on the right-hand side that will resemble what I have here. So first what I would probably want to do is, since I have a binomial squared, just go ahead and square it. And the result is cotangent squared x minus 2 cotangent x cosecant x plus cosecant squared x. So I'm seeing cotangent squared, I'm seeing cosecant squared, so that's going to make me want to look here. And cosecant squared is equal to 1 plus cotangent squared. So maybe that would be a good substitution. So I'll try that. Cosecant squared is 1 plus cotangent squared. So I have the same cotangent squared x minus 2 cotangent x cosecant x. And then here, I'm going to replace cosecant with 1 plus cotangent. Then at that point I can see, okay, good, now I'm going to have 2 cotangent squareds. I'm going to have a minus 2 cotangent cosecant x. But then I have this 1 hanging around. So I think, maybe that's really not helping me get to where I need to go. Maybe an alternative thing that I could try is going back to replacing cotangent and cosecant with some sort of version of sine and cosine. So usually there's 2 go-to strategies in a situation like this. Either do a Pythagorean substitution and see if it gives you anything simpler, which it did not, or to try using sine and cosine as much as possible. So I want to rewrite everything on the right-hand side in terms of sine and cosine exclusively. This is also motivating because over here on the left-hand side, everything I have is exclusively in terms of sine and cosine. So replacing cotangent squared is cosine squared over sine squared. Then I have minus 2, cotangent again is cosine over sine. Cosecant is 1 over sine. And then cosecant squared is 1 over sine squared x. And then this is exciting because now all 3 of those denominators are sine squared x. And that's doubly exciting because over here my denominator is a sine squared x. So now I know I'm on the right track. So now I want to rewrite this as cosine squared x minus 2 cosine x plus 1 over sine squared of x. And then I had this aha moment of, wow, that can be factored into cosine x minus 1 quantity squared. And cosine x minus 1 quantity squared and 1 minus cosine x quantity squared are equal to each other. So now I can rewrite the left-hand side as cosine x minus 1 quantity squared over sine squared x, and then I'm done. So that one was trickier. Sometimes you have to try something, it doesn't work, you try something else until you get to your answer. So as a warning, this next part of the lecture is going to cover problems that are due October 6th. So do not watch this lecture until you have attempted the textbook problems on your own. That is, don't watch from this point on, okay? So stop it here now and then come back later after you've already done the textbook problems that are due on October 6th. So, once you are here now for number 59, what is number 59? Okay, make sure that you never cross multiply when you come across a fraction like this, because the directions are not to solve for x. We're not back in a proportion section of intermediate algebra. We are trying to verify that the left is equal to the right. So the left and the right cannot interact with each other. Draw the big red line. What I want to notice, though, is that tangent squared, remember, has a relationship with secant squared. And you can find that relationship, just like all the other identities, right there in the back of the book. You see that tangent squared would equal secant squared minus 1. So I'm going to go ahead and rewrite this as secant squared minus 1. So that substitution right there is one of the Pythagorean identities. Now what I want to do is I want to factor this because this is a difference of squares, and one of the two factors is that denominator. So I've gotten this part to look like this part, but now I have some extra stuff that I have to figure out how to get rid of. If you know that this part needs to stay intact, then don't tinker with it. But secant theta plus 1 somehow has to go away. would try to do in a case like that is multiply, and this is just an experiment, but if I multiply this fraction by cosine theta over cosine theta, what would happen? And I'm motivated to do that because secant theta is 1 over cosine theta. So I'm just thinking this through in my head without actually doing it. I'd end up with a cosine squared theta plus cosine. And then over here, that would become a 1 plus cosine. If I could turn this into a 1 plus cosine, that 1 plus cosine could cancel with that cosine theta plus 1, which tells me this is the right track, except that I don't want to use the distributive property when I multiply the numerators. I actually want to keep them as separate factors so I can cancel. Now before I do this though, I do need to have a line where I change secant into 1 over cosine. That was just my thought experiment to see if I was going in the right direction. So I want to leave the secant theta minus 1 intact. And then I want to transform this secant only to 1 over cosine theta plus 1. So keep your eye on the ball. Now we want to multiply by a cosine theta over cosine theta. And the result, I'm sort of running out of board space here, but I can squeeze this down here. I have cosine theta times cosine theta plus 1 over, this becomes 1 plus cosine theta times secant theta minus 1. And then don't cross through your work. Instead, you can check off that these two factors will cancel. And then you're left with, and I'm just going to draw a line over here, you would be left with cosine theta over secant theta minus 1. So now that you don't end up with the same situation where you run out of space, start at the top of the page. But this should have been down low right here. So just imagine that that line right there is down here, and now the left-hand side is equal to the right-hand side. Okay, now for number 61, I'm trying to adjust this here. Okay, I have a fraction pair here that need to be added together, and that seems pretty simple, especially the denominators are conjugates. So when I was copying it down, it would have been smart for me to go ahead and just leave some space, anticipating that I was going to need to multiply. So before you write down a line, think, am I going to need to leave any space in here so that when I write this down, I could squeeze in some fractions? Because you don't want to be writing your fractions like arms that are appendages sticking out of your equation. Instead, you want them right there in line with the text. So what I would want to do when I copy this down is make sure that the problem number is well out of the way. And then I would also want to make sure that I left some room for fraction multiplication. So if you write it down strategically, you can then squeeze in 1 minus sine theta over 1 minus sine theta for that second fraction. And then over here, I can put 1 plus sine theta over 1 plus sine theta. So make sure that you leave a sufficient space. Now I'm going to have a common denominator of 1 minus sine squared theta, which is good. That can become a cosine squared theta if I need it to. And for my numerator, I have 1 plus sine theta plus 1 minus sine theta, and that is then going to become 2 over cosine squared theta. Meanwhile, on the right-hand side, secant squared theta is 1 over cosine squared theta, and so then I can rewrite that as 2 over cosine squared theta, and now the right-hand side is equal to the left-hand side. For number 63, since cotangent is the reciprocal of tangent, it just seems like the most natural thing to do is to replace every occurrence of cotangent with 1 over tangent. Now I have a complex fraction, so I can clear the complex fraction, the little tiny denominators, by multiplying the entire fraction by tangent alpha over tangent alpha. Now, when I use the distributive property, I'll end up with 1 plus tan alpha over 1 minus tan alpha, and I'm done. I did not assign number 68, I assigned number 67. But 68 and number 67 are so similar that I will do 68 for you, and you should then be able to make any corrections that you need to number 67. First, I want to observe that the numerator is a difference of squares. Now, it also turns out that the denominator is a difference of squares as well. But in my mind, as I'm thinking about the factorization of the numerator, I can see that one of the factors of the numerator is the denominator. So I'm going to leave the denominator as is so that I can cancel it. Okay, hopefully you have perfected now your writing of alpha. It looks like a little fish. So now we are going to cancel sine squared alpha minus cosine squared alpha. Don't cross out your work, I need to read it. This leaves us then with sine squared alpha plus cosine squared alpha, which is conveniently equal to 1, and that was number 68. Now, I'm also not going to do number 69 because 69 has a solution available on Blackboard. So you can go there and check that out. And so the last problem I'm going to do is number 74 to complement your assigned problem number 73. Okay, here's number 74, and as I recommended earlier, if you know you're going to have to multiply some fractions by other fractions, make sure you leave sufficient space. I see here that both of my denominators are conjugates of each other, so I'm going to go ahead and multiply each of them by their respective conjugates, and that would give me a common denominator. So my new denominator is going to be 1 minus cosine squared theta, which is very nice because that will turn into sine squared theta. And for my numerator, okay, I've got a big numerator. So let's see, what do I want? I've got sine theta plus cosine theta sine theta. And then over here, pay attention to the fact that this negative will distribute. It's very easy to forget that the negative distributes, okay? So I'm going to have negative sine theta cosine theta times 1. And then negative sine theta cosine theta times negative cosine theta, which becomes a positive sine theta cosine squared theta. That was a little tricky. Now the good thing is here my two middle terms are additive inverses, so they will cancel. And now I just have sine theta plus sine theta cosine squared theta in my numerator. And then, of course, my denominator is equal to sine squared theta. And you can see already that you're going to have a sine theta cancel, so we want to go ahead and factor that sine theta out. Always factor before you cancel. Factor before you cancel. That's the rule. It doesn't matter how much you can do in your head right now. What matters is you demonstrating step by step the full communication of the process, outlining the entire argument. If you can get good at making perfect arguments in math, you have the logic to transfer that same argument skill to anywhere else. In math, you have no emotional bias. In other subjects, you do. You can transfer this to philosophy and all sorts of other contexts. That's why Plato thought math was one of the best, if not the best, subject for training your mind to think well. Okay, and lots of other philosophers. And some professors of mine in college. Not just those in the math department. Okay, so now I'm going to cancel the sign in the numerator with one of the signs in the denominator, and that is going to give me 1 plus cosine squared theta over sine theta. And then I probably would have continued just completely on the right-hand side, except that I've run out of board space. So I will come over here on the right-hand side and replace cosecant with 1 over sine theta. So then, of course, this is going to become 1 plus cosine squared theta over sine theta, and we are done. So hopefully this lecture was really helpful. We didn't have any new material to go over. We just needed additional practice as we work through these challenging proofs. See you in the next lecture.